Okay, so in this lesson, you are going to learn how to solve non-linear inequalities. So let's take a step back and recall what we've been working with. So if we had this inequality, 2/3 x plus 2 is less than or equal to, say, 3/4 x minus 4. We have fractions, and we want to eliminate the fractions by multiplying through by the least common denominator, which in looking at the denominators 3 and 4, the smallest number that both of those will divide into is 12. So I'll multiply every term by 12. 12 divided by 3 is 4, and 4 times 2 is 8. 12 times the 2 is 24. 12 divided by 4 is 3, times 3 is 9x, minus 48. And then pretty easy, I'll subtract the 9x from both sides and get that negative x plus 24 is less than or equal to negative 48. Subtract 24 from both sides and get that negative x is less than or equal to, what is that there? Negative 72. Now, because I'm going to divide by a negative, I do have to reverse the symbol, and x is greater than or equal to 72. And using interval notation, since it's equal to, I'm starting at 72 and including it and going off to infinity. Very importantly, this is a linear inequality. It is linear because it is of the form mx plus b. X to the first power is linear. So how we solved these was we basically treated it like a linear equation, except when we divide or multiply by a negative, we had to reverse the symbol. Okay, so once again, linear inequalities, treat it like a linear equation, distribute, combine like terms, except if in the end, when you multiply or divide by a negative, you reverse the symbol. Today's lesson, we're going to get into non-linear inequalities. Okay, so let's take a look at these. These are like your quadratics, your cubics. So a non-linear inequality, something like x squared minus x greater than 0. So this is not linear, and we can't treat it like one. And like when we had these equations before with x squared and x, we would set it equal to 0 and factor. We'll have factoring involved, but that's not all that we do. So let me give you the steps in how we're going to solve a non-linear inequality. The first step is to set it to 0. So set to 0, whether it's greater than or less than, set it to 0. Step 2, here comes that factoring, factor completely. And number 3, we'll go to the number line test, hashtag number line test. And step 4, write your solution. Okay, and I'll also explain this graphically using your graphing calculator tomorrow. So again, we're solving non-linear inequalities, and we're going to use these steps, and I'll fill in the gaps as of why we do those steps. So here in this problem, we are set to 0 already. So step 1, the inequality is already set to 0. Step 2, we're going to factor completely. So I'll start with the GCF by taking out an x, and this is what I have. Step 3, in order to do the number line test, you need critical points. Your critical points come from setting each of these factors equal to 0 and solving for x. So this critical point would be x equals 0, and this critical point would be x equals 1. And you make a number line with those critical points, 0 and 1. Because there's no equal to on this inequality symbol, both of these values will get an open circle. If it had an equal to symbol, like greater than or equal to, or less than or equal to, they would get a closed circle. And now we're going to do what is called the number line test. And that entails picking a number, any number to the left of 0, putting it here for x in the factored portion, and seeing what sign you get. So a number less than 0 is like -10, -5. Any number less than 0, the more obvious you make it, the easier the computation is. And I'm going to put that number back in here for x. So that would be a -10. -10 minus 1 is a -11. And a negative times a negative is a positive. All I'm recording is the sign I get, not the value. Now pick any number for x between 0 and 1. Well, how about a half? If I put a half in here for x, I obviously get a positive, and a half minus 1 is a -1/2, and a positive times a negative is a negative. If I pick, say, 5, any number to the right of 1 for x, I put that in here for x. A +5 times 5 minus 1 is a +4, and a positive times a positive is a positive. And there's my number line test. What this tells me is it tells me where the function right here is positive, negative, and positive. What that means is for these values of x, the y's are all positive. For x's between 0 and 1, all the y's are negative. And for all x's greater than 1, my y's are positive. It's also, we're going to learn where the graph is above the x-axis. Because if I gave this to you here as my graph, this parabola, say, passing through the points 1 and 3. When the graph is above the x-axis, that's where the graph is positive. When the graph is below the x-axis, that's where the values are negative. So it's above, positive y values, below, negative y values, above, positive y values. So we want the x's, the values, that are greater than 0. So I will shade where the number line is positive, because positive is greater than 0. If this problem were less than 0, then I would shade where the number line is negative. So positive is greater than 0. You make one note, because some students mess that up, and negative is less than 0. My solution set in step 4 using interval notation is from -infinity to 0 in union with 1 to infinity. And you could enter your answers just like that into Delta Math. Now, something also to pinpoint is notice how the signs alternated. Positive, negative, positive. The signs on the number line will always alternate from one to the other when these exponents on your factors are odd. Anytime the exponents on the factors, once you factored it, are odd, they will always alternate. All right, so let's do some more examples. Suppose we have x squared plus 2x equals -8. Oh, bad. Greater than or equal to -8. So the first step is set it to 0 by adding 8. Scratch that one. I meant 6x. Man, I can't see. So it'd be x squared plus 6x greater than or equal to -8. So first step, I guess that could have worked if I kept it. All right, set it to 0. Second step, reverse FOIL. Everything is positive. X and X, factors of 8 are 4 and 2. So at this step, you cannot do what we did with equals. You cannot write this step. That is not true. That is not true. So you set it to 0, you factor completely, and from there, you do the number line test. What are your critical points? When each of these equals 0. -4, -2. So you put them down in the right order from, smallest to greatest. Because I have the equal to, I'm going to put closed circles here and here. And now I'm just going to do the number line test. Pick any number for X less than -4. Make it look obvious, like I said. You can pick -10 again. You put that in for X. So -10 plus 4 is a -6. -10 plus 8. -10 plus 2 is -8. And a negative times a negative is a positive. If you feel pretty confident that you are correct, they are going to alternate signs. Positive, negative, positive. They have to alternate signs whenever these multiplicities, these exponents on those factors are odd. To confirm things, if I pick, say, -3, because that's a number for X between -4 and -2, -3 plus 4 would give me a +1. -3 plus 2 would give me a -1. And those values multiplied would give me a negative. Again, this would mean where the graph of the parabola is above the x-axis. These are the x's for when it's below the x-axis, and this is when it's above. In step 4, I want greater than or equal to, so I'm going to shade my number line wherever there are positive signs. And that would be -infinity to -4 bracket now, because I'm including the 0 in union with -2 to infinity. Okay, so that's example 2. Example 3. Suppose we have let's take a look here at 2x² plus 9x is less than 56. So the first step is to set it to 0. Now pause the video and see if you can factor that. Pause the video and see if you can factor it. This factors into, there's a negative on the end, positive and negative. There is no GCF, by the way. 2x and x gets me 2x². Factors of 56, that will add or subtract here with the 2 and the 1 to give me a 9. I'm going to try 8 and 7, obviously. So let's see how this works. 8 and 7, you must check the outer. -16x plus 9x is, 7x, that is, which is -9x. I need a positive. So therefore, I'm going to try switching the signs. Now I have a positive 16x for the outer term, -7x for the inside, and that gives me a +9. So I now have the correct factors. Step 3, set each of these equal to 0 to get your critical points. Add 7 and divide by 2. So x would be either 7/2 or -8. So -8 goes first because it's smaller on the left, larger on the right, of course. We're doing the number line, and that's 7/2. So those are my critical points. I got them in the right order. Now do I put an open or a closed circle? Because it's just strictly less than, there's no equal to, they will get open circles. They will not be included in my solution. Give me any number to the left of -8, such as -10. Again, put that in for x. Well, that gives me a -20 minus 7 is a -27, but I don't care about the value. I just need to know the actual sign. And -10 plus 8 is a negative, and a negative times a negative is a positive. A 0 is a nice number between a negative and a positive. 0 into here produces a -7. 0 in here for x produces a +8. Negative times a positive is a negative. And notice how they alternate signs again, because these factors are of odd multiplicity. I want this time where it's less than 0, the function. So I'm going to shade on the number line where it's a negative. And that will be now in step 4, the interval from -8 to 7/2. Next example, x squared greater than or equal to 4. No, you cannot undo that by plus or minus the square root. It is non-linear. Set it to 0 by subtracting 4. This is a difference of two squares technique. So x minus 2 and x plus 2. My critical points are either 2 or a -2. You can see that there by sight. Set each of these equal to 0, and solve them. And because of the equal to, when I put these down the number line, they will get closed circles. I'm going to try picking, say, -10 again. Putting that in for x, I'll get a -12 times a -8 is a positive. And if you're very accurate with that, you know they have to alternate signs then, because these are odd multiplicities. I want greater than 0, so I'm going to shade where the number line is positive. And in step 4, write my solution. This will be from -infinity up to -2 with the bracket, in union with bracket 2 to infinity. Next, suppose now we have something that is factored and set to 0. So first, we have it set to 0. And we have it factored. So steps 1 and 2 are done. Step 3, number line test. Set each of these factors equal to 0 to get those important points called critical points, -3 and 1. Well, I'm still doing step 3. I'm going to put down -3, smallest first. 1 goes next. Open circle for both of these because I don't have the equal to symbol. But now this time I have to be careful because the signs will not alternate because I have an even power on my factor of x plus 3. That's an even multiplicity. So that means at the critical point -3, the number line will not change signs. It will either be negative on both sides or positive on both sides. How do you know? Pick any number for x to the left of -3 on the number line, like -10. You put that in for x, and -10 plus 3 is a -7. But you should know anything squared is a positive. So this is a positive number. And when x is -10, -10 minus 1 is a -11. And a positive times a negative is a negative. That means if you use my shortcut, it's got to be negative on both sides. Why? Because it came from an even multiplicity. Now, if I pick, say, 5, which is to the right of 1 on the number line, I can pick 5, 10, any number you want. It just has to be greater than 1. Put that in for x into each of these. 5 plus 3 is 8, squared is a positive. 5 minus 1 is a positive 4, and a positive times a positive is a positive. It will change signs. The number line will change signs at 1 because that came from an odd multiplicity. So my answer, where am I less than 0 for step 4? Negative infinity to negative 3 in union with negative 3 to 1, because this is where the number line is less than 0. Okay. Next one, suppose we have let's take a look at this one. X cubed minus 2x squared minus 9x plus 18 is greater than or equal to 0. So I have it set to 0. The first thing I'm going to do, well, I did that, set it to 0. Step 2, I'm going to factor. How do you factor 4 terms? Well, we're going to try factoring by grouping. Group the first 2 by taking out an x squared. And what's left is x minus 2. From the last 2, take out a minus 9. And what's left is x minus 2. Be careful. Take out a negative 9, and what's left is x minus 2. You take out your GCF, which is x minus 2. And what's left is x squared minus 9. But now we want to factor that further. We're not solving it. We want to factor that further. So this would go x minus 2 times x plus 3 and x minus 3, because there is a difference of 2 squares. My critical points are found when you set each of these factors equal to 0. You could either see it by sight or writing out those small equations. But those are my critical points: 2, -3, and 3. In step 3, I make a number line test. Again, make sure you put them in the right order. I have done that mistake by accident. -3, 2, and 3 all line up from smallest to greatest. Because of the equal to, they will all get closed circles. They will be included with brackets. And now I'll do my number line test. If I pick a -10 for x, I'll get a -12, which is a negative. -10 plus 3 is a -7. -10 minus 3 is a -13. An odd number of negatives multiplied is a negative. Now, since these powers are all odd, they have a multiplicity that is odd. They all have a factor of just 1 here. That means all these critical points, they have to change signs. So if your first one is right, okay, it will go negative, positive, negative, positive. Now, if that first one is wrong, suppose this should have been a positive for your first one, then all the other numbers are wrong. So that first one really has to be, correct, so that when you alternate them, the remaining are correct. Where are we greater than or equal to 0? Wherever the number line is positive. And that's going to be a bracket at -3 to 2, bracket, in union with bracket at 3, going off to infinity. Okay. And one more. Suppose we have x plus 2 squared times x minus 3 cubed times x plus 1 less than 0. So what's nice about this, it's already set to 0, and it's already in factored form. What are our critical points? Set each of these equal to 0, and x would either be -2, 3, or -1. You don't have to do this step if you could just see it. Now I ask you to look carefully at the powers, those that are odd, those that are even. Which critical points will the number line alternate signs? It will alternate signs. The number line will alternate signs for the critical points where the powers are odd. And that's at critical points 3 and -1 because they came from the odd powers. The even power critical point, if you will, the -2 came from the even power, the even multiplicity. That means it will not change signs at -2. It has to be the same sign on both sides. But we don't know which one it is until we start doing the number line. -2, -1, and 3. So now if I pick, say, -10, I don't have to do this because I know it's a positive. Anything squared is a positive. -10 minus 3 is a -13. A negative cubed is a negative. -10 plus 1 is a -9. To the first is a negative. Negative times a negative is a positive. Times a positive is a positive. I really don't have to do any more work. If I know that first one's correct, I'm good to go. Because at -2, it came from an even multiplicity, it has to stay positive on both sides then. If the first one's positive, the second one has to be positive. The remaining critical points came from odd powers, so they're going to alternate signs, positive to negative, negative to positive. Or you can pick numbers to verify that. Between -1 and 3, you can pick 0. This is always a positive for the first one. Anything squared is a positive. 0 minus 3 is a -3. Cubed is a negative. 0 plus 1 is 1. Square to the first is a positive. And a negative times a positive is a negative. Where am I less than? Open circles. Sorry about that. Left that out. Where am I less than 0? From -1 to 3. Okay. And just one more. Suppose we have x squared. Let's make that x. Let's do one here that's a little different. You practice with the reverse FOIL. So let's do 6x squared minus 7x minus 20 is greater than or equal to 0. So for that first step, it is already set to 0. The second step, I'm going to try and reverse FOIL here. There is no GCF to take out. And I'm going to try 3x and 2x to give me the 6x squared. Negative on the end, positive and negative. And the factors of 20, I'm going to try here, I don't know, 5 and 4. That gives me a -15 plus 8 is a -7. I have the right combination. My critical points are found, again, from setting these equal to 0 and making these small equations, subtracting 4, dividing by 3, adding 5, and dividing by 2. So my critical points this time are fractions, which is certainly fine. I'm going to make closed circles here on each because they'll be part of the solution. Now this is -1 1/3. I don't have to pick a fraction. So pick -10. That's still a number less than, -1 1/3. So a -10 in for x here makes a -30 plus 4 is a negative. -20 minus 5 is still a negative, and a negative times a negative is a positive. And I don't have to do anything else more because these powers to these factors have an odd multiplicity. It has to alternate signs, positive, negative, positive. Since I'm greater than 0, I'll shade where it's positive. And the answer now will be from negative infinity to negative 4/3 in union with 5/2 to infinity. And that concludes this lesson on solving nonlinear inequalities the algebraic way.